Hello and welcome back. This is our last video lesson for the week. Don't worry, you're going to get more coming up. We are going to look at our Khan Academy again, Fibonacci. We're going to be dealing with ratio application. Ratios and units of measurements. This is how we will usually be using our ratios in the real world. And we're going to see that in Fibonacci architecture too. We know that a ratio is a method of comparing two quantities. We understand our equivalent ratios. We've assigned double number lines to our ratios. Now it's time to assign units of measurement. What can we measure? How tall you are, how much you weigh, how much a cup of soda costs, how much it would cost for half a pizza instead of a whole one, which is crazy. Who doesn't want a whole pizza? When we have our units of measurements, we can say how tall we are. And you answer using the unit of measurement you're used to. In America, we have the customary system. In Europe, they have the metric system. So we're going to start with a little bit of an example using our customary units or inches. Miss Pilto's short. You all know this. I am short. I'm shorter than most of my students. That doesn't tell me how short I am, though, and it doesn't tell you how short I am, though. If I have a number, if you have a number to how short Miss Pilto is, you can better visualize or imagine how short she is. Miss Pilto says she's 4 feet and 10 inches tall. If Miss Pilto was 4 feet and 10 inches tall, how many inches is she total? So we're going to break down this feet section primarily because we cannot say 4 feet and 10 inches and compare that to another single number of measurement unless those two numbers are of the same unit. So we have to look at the same unit depending on what our problem is. And our problem here is how tall is she in inches? 12 inches goes into 1 foot. 12 inches, 1 foot. If Miss Pilto's 4 feet tall and I have to figure out how many inches in each of the feet she is tall, all I got to do is multiply 4 times 12 because I'm adding 12 4 times because it's 4 feet. That gives me a total of 48 inches. But wait, is she 40 inches tall? No, because she has 10 more inches. Miss Pilto was 58 inches tall. Now let's say you're enjoying a walk around your block during the quarantine. You come across Miss Pilto, me, walking her precious dog. And here's a picture of him and a picture of me when my hair was shorter. Her precious dog, Govinda. He only goes up to her knee. You lean down and pet the dog. He is super sweet and jumps up on you for a hug. When Govinda stands on his hind legs, he is 1/3 Miss Pilto's height. 1/3 of her total height, which is 58 inches total height. How tall is Govinda in inches when he stands on his hind legs? Let's figure it out. If Miss Pilto is 58 inches tall and Govinda's 1/3 of her height in inches, the best way to figure this out is to divide 58 by 3. We're going to get into that math. Again, he's a cutie pie. He's a sweet. 1/3 times 58 over 1. It's kind of a weird way to arrange the problem, but it's going to help you see how you can use these particular numbers. Note, a whole number can also be seen as a fraction. Just a whole number over 1. It stays a whole number, but when you put it over 1, that invisible 1 can help you when it comes to the two fraction ratios. So we have 1/3 the height of Miss Pilto, but 58 over 1. It's going to make it easier to figure it out. Then we're just going to multiply across. 1 times 58 is 58. 3 times 1 is 3. 58 over 3, or 58 divided by 3, is 19.3 inches. Govinda is 19.3 inches tall when he stands on his hind legs. Excuse that typo there, 19.3 inches. And here's how I broke it down using my dad, mom, sister, brother method. Divide, multiply, subtract, and bring down, and sometimes R or rover for remainder, because we do have a remainder in this problem. 3 goes into 5 once, because I can't take out more than that one set of 3. So then I have 2. I bring down my 8, which gives me 28. 3 go into 28. It goes in 28 9 times, because 3 times 9 is 27. And now I have a remainder of 1. 3 cannot go 1, so it's my remainder. However, the number 1, if I add it 3 times, will give me 3, so it's 1/3. And if I turn that into a decimal, it's it's 0.33. So this is a little trick I used. And you can use this too as well. You put your dividend here, right here. 3, go into 58. Mom, sister, brother, divide. 3 goes into 5 one time. Multiply. 3 times 1 is 3. Subtract. 5 minus 3 is 2. B, bring down. I brought my 8 down. And R, my remainder. Here's your takeaway. You may have to divide or multiply as seen fit by your problems. Remember to read the problems more often than once. Pinpoint your keywords and numbers. Use the 3 reads method. If you are unfamiliar with a unit of measurement, look it up. For example, meters may be more confusing than feet. Khan Academy will usually provide measurement comparisons. And again, watch the videos. And now to our enrichment. We are familiar with the ratios of the Fibonacci sequence approximating the decimal 0.618. What is so unique about the golden ratio is that no matter how many times it builds upon itself, the smaller part divided by the larger part will always approximate 0.618, just as dividing the larger part by the whole, meaning the larger part and smaller part together is the whole, will also give you that ratio. Here's a visualization of it. So again, it is assigning letters in place of numbers. Here we have the whole line. A is the larger part. B is the smaller part. A plus B together makes the whole. Divide by A equals the larger over the smaller part, which will give you 1.618 or 0.618. We're usually going to see a whole number in front of here, but that just means you're adding on extra sections, but that does not take away at all from the ratio. 1 represents the whole plus the ratio. Here, in a monument in ancient Greece, I'm part Greek, we use ratios and parts and wholes in order to create fabulous architecture. See how things have been broken down here? A moment, breathe it in, it's beautiful. And in our face and bodies. Head to heel, head to fingertips, head to navel, head to top part of the inner arm. Everything fits itself. So again, stay happy, stay healthy, stay safe, stay inside, and I will see you in class.